Hello and welcome back. Today is day 6 of our graphing quadratics unit. We will be summarizing the 3 types of quadratics in this lesson. Remember that you can download the handout for this lesson in the description below. Thank you and enjoy. Alright, so we don't have a warm-up today because we're going to try to get through this really quickly. But let's take a look at standard form. So again, we see right here in the top left-hand corner, this equation is written in standard form. So we got y equals a times x squared plus bx plus c. Alright, and then we have a slider for a, b, and c. And our job is to figure out what does A do, what does B do, and what does C do to this graph. So let's start off with A. You probably already know what's going to happen when we move around A. So as we make A larger and larger, this graph's getting tighter and tighter. And then as we get smaller in here, it starts getting a wider graph. And then as soon as it hits negative, then it starts going concave down. So if again, you've already seen that with the other one, so we should know what A does by now. And it's a linear graph when A is 0. Why is that? That's a good question. Why is it a linear graph right now? How come when A is 0 it's a linear graph? Well, if you look up at your equation, if A is 0, that means 0 times x squared. That means you're not going to have an x squared term. This is going to be gone. So you're just going to have a linear function. So that makes sense. So pretty interesting. So A, we're going to record that into your notes. So if you can pause the video real quick and just record that. So A is going to determine if it's concaved up or concave down. All right, now coming back here, what does B do? So what does B do to this graph? This looks kind of cool. So what's happening here? As B goes positive and negative, it looks like I'm moving my graphs a little bit left and right. But also what I noticed is my vertex is changing all the time. So my vertex changes. So my vertex goes up, goes down. It's going up, and then it goes back down. So my vertex is always changing. But what is the one interesting thing? What's interesting is that I see here, no matter what I change A to be or B to be, it doesn't matter. Whatever I change those to be, that I notice that I still have the same y-intercept. So no matter what happens, if A is positive or negative, I have this y-intercept. If B is positive, no matter where it is, or negative, I still have the same y-intercept. Alright, so then obviously it kind of leads us to, what do you think C is going to do? Well, C is going to move my graph up and down. But what else do we notice? What happens when C is -1? What do we notice here? We notice that this point right here is 0, -1. And what do you call a point on this line? That's my y-intercept. So what I notice is that C, no matter what I change it to, if C is 4.7, there's my y-intercept at 4.7. So no matter what happens, let's make B, oh, look at B's changing, but my y-intercept is never changing. Alright, A is changing, but my y-intercept's never changing. Whatever my C value is, -4, guess what? You have a y-intercept of -4. So again, I'm going to need you to record this into your notes real quick. Tell us what A does, what does B do, and what does C do to your graph. Alright, good job. Alright, so this little graphic organizer is going to be what we're going to use to kind of summarize our thinking. Again, this is going to be a great place for you to go back and look at your notes, and when you're doing other work, just a quick review of some of the big ideas. So what you should notice here, we have quadratic equations, and we have 3 different types. Then it asks us to fill in an equation, what's the key information, what a sketch looks like, concavity, and axis of symmetry. Alright, so let's go to the first one. I zoomed in a little bit just so we can see a little better. So vertex form. What is the equation for vertex form? Well, we should know it's y is equal to a times x minus h squared plus k. Perfect. Alright, and what is the key information? Well, again, when we did our investigation, vertex form, the key information that it told you was the vertex. So, I mean,
easy name. And what is the vertex? The vertex can be found at whatever h is and whatever k is. Okay, so again, that's what we learned for that one. And let's draw a quick sketch of it. So again, I just need a quick sketch. So let's draw an axis in here. Doesn't have to be perfect. Here's my axis. Let's draw a parabola. Here's my parabola. Perfect. And the key information that this graph tells us, it tells us this point right here. It tells us this point, the vertex, which is h and k. And perfect. Okay, so again, we studied vertex form just so we can know this. We can know that part right there. Let's go with the next one. So factored form. What does factored form tell us? Well, first of all, the equation looks like y equals a times x minus r sub 1 times x minus r sub 2. All right, and what does this tell us? The key information from factored form is that we should know the roots. We should know what the roots are. So the roots for this problem is going to be, well, we have one root, and remember roots are on the x-axis, so that'll be r1 comma 0, and my other root will be at r sub 2 comma 0. So we should know from factored form, whenever you look at factored form, you should know the roots. So let's make a quick sketch of that, see what that looks like. So draw yourself a parabola, perfect. And now this time, what do we know? We know these 2 points. So we know this point and this point, those are our roots. And this one, I'm just going to call this one at r1 comma 0, and this will be r2 comma 0. Okay, perfect. And let's do the last one. Last one is standard form. So standard form, what's standard form? That should be the easiest one to remember. Just ax squared plus bx plus c. Okay, so that's standard form. Now, what was the key information? That's what we did today. So the key information, what we knew from standard form, was the y-intercept. Okay, so that's what we know. And what was the y-intercept? It's always c, whatever the c value was. So y-intercepts are going to be 0, c. So that's going to be the coordinates of your y-intercept. So, for instance, let's sketch a graph. Let's see what that looks like. So here's my quadratic. I'm going to draw a quadratic equation in here. And we know the y-intercept. So the y-intercept will be this point right here. That'll be 0, comma, whatever c is. All right. So again, each form has one thing that's really obvious, really key for us to be able to graph. So vertex form, remember, it's going to tell you the vertex. Factored form will tell you the roots or the zeros. And standard form will tell you the y-intercept. Okay? We're going to continue to add more to this information, and we'll talk a little bit more about the rest of it. Continue on here. So now, let's talk about concavity. Now, you should remember that concavity was, what was concavity? What told you how this thing opens up or down? Remember, it was always the a value. And what you should notice is that each one of these has an a value. So there's an a in every single form. So how do we know if it's concave up? So if a is greater than 0, so if a is positive, that's what a is greater, only numbers that are greater than 0 are positive numbers. So if a is positive, then concave up. And if a is less than 0, then concave down. And the same thing happens here, here, and here. So I'm not going to write it over and over again because that's just going to say the same exact thing. So again, remember the a value in each one of these forms let you know if it was going up or if it was going down. So if it was concave up or concave down. For this next part, the axis of symmetry, we are going to save that for later. Okay, so I want to do a whole little idea on this one, so we're going to do this later. So in the next lesson or the next following lesson, we're going to come back and fill this in. But for right now, that's the big idea for today's lesson. Usually I don't do the homeworks with you. I don't start those. But again, for this one, just I want you to sketch it and I want you to see what I want it to look like. So for problem number 1, it says sketch a graph of each function. And then remember, you can check all your answers on Desmos. Go on Desmos, graph these real quick to make sure that you're correct. But for a sketch, all I want to see is give me like just a generic view of what does this quadratic look like. So for the first problem, what form is that written in? So I noticed the first one is written in vertex form. So that's in vertex form, which means you should know the vertex. So the vertex for this problem, oh, sorry. The vertex for this problem is going to be 4 and -3. And remember, H always, when you look at vertex form, H has a negative in front, so that means the sign's going to switch. So this is going to be a +4. I know in the equation it says -4, but it's going to change to a +4. All right. The last part, C, or K, is going to be exactly what it is. So if it says -3, it's going to be -3. So that tells me what? That tells me that you have a vertex at 4, -3. So 4, -3 is going to be somewhere right around here, somewhere in the 4th quadrant. Now, the second thing I need you to figure out is just, is this graph concave up or concave down? Well, look at what A is. So A in this problem is a 2, which means that this is concave up. So then just sketch me a graph. Oh, I missed. Sketch me a graph that goes through the vertex, and it has that point. So this is my vertex. It's at 4, -3, and voila, you're done. Okay, so for these, I don't need it. I don't need all these points. I just want the key information and sketch a graph. So I really want to know if it's concave up or down and the key information in each problem. Okay. All right. Good luck.